Okay, we just went through the basic syntax for differentiation. Capital D, bracket open, the function and the variable. And basic syntax for repeated differentiation. Specify the repetition by brace open x comma k. And then we went through an example for integration, but then again we did it just once, and we did it in this notebook. So let's do this again using the blank screen. Let's select problem C of this problem. Cosine of t over square root of 1 plus sine squared of t dt. As a matter of fact, no, let's do it with problem B. I have a feeling that problem C may turn out to be too complicated. It has some inverse trick substitution and inverse trick functions all around, so it looks like it's going to be too complicated. Let's do problem B. Okay, here we go. We have this blank screen again, as if we just opened Mathematica and got this default screen. And let's type in the Mathematica command here, integrate. And the square root y times e to the square root of y comma y by specifying the variable, and run it by shift enter, and then we have an answer here. By the way, here I have square root of I, and then we have e to the square root of I. By putting nothing in between, Mathematica understood it as a multiplication. I can specify it as multiplication by putting the star in there. If you want to find out the definite integral, you can do something like this. In order to save some time, let's copy and paste, and then run this integral from, let's say, 1 to 2. Okay, let's do that, and then run it, and then here's the answer. That is the correct expression, and I like it. But let's suppose that we want to find out the numerical value of it. In that case, what do we do? Basic syntax is n integrate, and then we have to integrate it from 1 to 2. So numerically integrate, and then we get 4.20138, and that is the approximate numerical value of the definite integral got from 1 to 2. Okay, these single line expressions are nice and concise. However, they are not the most desirable. As you can see, this expression here, compare this expression and then the expression down here in my notebook. Which looks better? Well, this Mathematica symbol certainly looks better. So let's discuss how to pull up these mathematical symbols down here, and also what are the list of Mathematica commands that we will be using, functions and so on. And rough answers will be given in the right hand side box over here, where I'm moving my mouse around. Basic Math Assistant. So let's discuss how to get this Basic Math Assistant and how to use it. Okay, let's kill this window, Basic Math Assistant window, and then let's reopen it. You have to go to Palettes in this top menu bar, Palettes. Once you click, the very top one is the Basic Math Assistant palette, and that's because that's the most popular and that's the most important. It has several sections here: Calculator, Basic, and Advanced. Click Advanced and I have more tools here, like integration symbols and summation symbols and things like those. Basic is a bit simpler, and then I can minimize this part, and basic commands, and then we have a lot of commands here. Trigonometric function should be sine, sin with capital, cos with capital, and so on. The list of those trigonometric functions are here, and well, there are some other functions here like ceiling, round. You can see a lot of those things. And then let's see, if you go to the third box over here in basic commands with D and integral symbols, you can see some symbols regarding, Mathematica commands regarding calculus. D for derivative, limit for limit computation, integrate for integral, integrate for definite, and so on and so forth. So these give you kind of sort of library of what to do. So you can explore appropriate command from here. And typesetting. Here the default, the first box has a variety of subscripts and superscripts and so on. Oh, how to get fraction is there, some matrices and some, well, integrals and things like derivatives and things like those are there. The second box with this infinity and Greek beta symbols, well, that will give you a variety of characters. The third one will give you algebraic expressions and so on. So please explore these windows here to use a variety of symbols. Now, if you want to calculate integrals or do something advanced with these basic math assistants, you can do something like this. Let's go to File and open up this default interface, which doesn't look too good. And let's expand the font a little bit. And this time we're gonna use this basic math assistant window, this right hand side box, to get a little bit better symbols. Okay, let's do some integral computation. Let's go to this basic math assistant and calculator, and let's click advanced. And advanced has a lot more symbols. And can you find integral symbol here? Yes, I just found it here. Okay, and integral symbol just showed up in my Mathematica main window, and specify the variable as x, and then let's type in something. And what shall I type? Fraction. Okay, fraction, and then get a square root in numerator. So 1 plus log of x over x. Okay, that looks as good as any. And then let's calculate this antiderivative. And then here's the answer. So this computation, this expression over here is equivalent to this. Integrate and square root 1 plus log of x over x comma x, and of course we have the same answer here. Now let's compare this basic Mathematica syntax versus this fancy looking notation given by my basic math assistants. Which is easier to understand? By far this one. So please practice how to use this Palette basic math assistants. If you want even more interesting symbols, you can go to Palette and you can explore a lot of other things here too. But even the most basic math assistants, the simplest one, has a lot of tools here already. What if we want to find out the definite integral? Let's use definite integral notation here, and then let's calculate the definite integral from 1 to, say, e, and then this time let's use character y, and what shall I create here? Fraction, and the numerator, let's put I don't know, just 1. and denominator y times log of y. Oh, looks like this is not gonna work very well because log of 1 is 0, so denominator will turn out to be 0 if you do it like this. So let's change this one into e to 2e. Okay, e to 2e, that's as good as any. And let's calculate this definite integral. And then here's the answer. This is equivalent to this. Integrate 1 over parenthesis open y times log of y, brace open, y is running from e to 2e. And here we go. Okay, so using this basic math assistance, you can calculate a lot of integrals with mathematical symbols and with reasonable accuracy. If you forgot about internal mathematical commands for trig functions and inverse trig functions and so on, or exponentials, go to this basic math assistance advanced. They're all here. Sine, cosine, tangents, log, they're all here. So for example, if you want to calculate the definite integral with some sine functions from trigonometric function, let's go to this, and then from 0 to go upper, let's find out pi. Okay, pi is here. Make it 2 pi. And then let's go to sine of x, sine of x squared dx, and let's see, I have a feeling Mathematica may not be able to calculate that. It may. Let's just run it. Okay, it did calculate, but it used Fresnel function, so it's rather complicated. Let's use x sine of x squared. Yeah, that's much simpler. And then the answer turned out to be pi of 2 pi squared, total quantity squared. And pi symbol is always also supported by basic math assistance. And what if you want to find out the numerical value of it? There are two ways to handle that. One is to use n-integrate, which actually does the computation numerically. Or you can do something like this, /n, and that is not exactly the same as n-integrate. This one completely does all the computation symbolically, and then at the very end, find out the numerical value, /n. So run it, and then you're going to get the numerical value of it. If you want symbolic value back, throw away this /n, then you're going to get something like that. What if you want to find both of them? Just keep it, and then copy and paste. Oops, wrong place. And then we have symbolic answer, and then we have numerical answer. Oh, what if you want to find out the indefinite integral as well? There are too many things on top, so let's erase all these. What if you want to find out indefinite integral too? Then okay, let's copy and paste, and then just change this definite integral into indefinite integral simply by erasing all these boxes. And then this gives you the antiderivative computation. So use basic math assistant box, and then use your common sense, and you can calculate a lot of integrals rather effectively. I'll leave more there should be more exercises, of course, but I'll leave the details to the students.